Welcome to this webinar on optimizing embryo transfer. And it's particularly fitting today that we're going to review Embryoglue, given that it is 20 years old this year. So what I'd like to do in the next few minutes is tell you what Embryoglue is, how it was developed, what are the functions it has, and what does it do clinically. So what is Embryoglue? Embryoglue is a medium that we designed specifically for embryo transfer. It's characterized by high levels of hyaluronan, and therefore it's based around physiological data on the composition of the uterus at the time of implantation. Furthermore, rather than having serum albumin in the medium, as you can see, it contains human recombinant albumin. And therefore, not only is it one of the most effective transfer media, but it's also the safest. So how is it developed? The preimplantation embryo is dependent upon the environment created by the oviduct and uterus as it develops and differentiates. Therefore, by analyzing the composition of these fluids, we get a good insight into what it is embryos are exposed to and require. For example, in the 90s, we were able to take samples of oviduct and uterine fluid and quantitate the levels of pyruvate, glucose, and lactate. And what we found was that there were differences between the oviduct and the uterus in their levels of composition. And it was upon this that we were able to base sequential media, G1, G2, G1 reflecting the levels of carbohydrates in the oviduct, G2, those in the uterus. But clearly there's so much more in oviduct and uterine fluids than carbohydrates. Indeed, there's an abundance of amino acids, and one can detect increasing levels of cytokines and growth factors as one progresses along the female tract. Back in the 90s, we were particularly interested in the levels and effects of different macromolecules. The reason for this is that the fluids of the female reproductive tract are not simple serum transudates, but are specialized environments created for the embryo itself. And during the 80s and 90s, serum was the typical addition to embryo culture medium. So we were interested in looking at different macromolecules other than serum. So we compared the efficacy of some synthetic molecules such as polyvinyl alcohol. We looked at dextran, but we were also interested in the levels and effects of glycosaminoglycans because they vary with the cycle. But it should be noted that there's an abundance of albumin and mucins within the female tract as well. So it's not just one macromolecule, it's two or more that act in synergy. So this is hyaluronan. It's a very elegant compound. It's a glycosaminoglycan, but it actually lacks a protein moiety, and therefore technically you could say it's a polysaccharide of repeating units of beta-glucuronic acid and N-acetylglucosamine. It can exist in short-chain oligomers, but it can also exist in large macromolecule forms, up to 10 million kilodaltons in size. Now, hyaluronan is a polyion and therefore can attract water, and as a result, it changes the composition of the fluids around it, so they become more like a hydrated gel. Indeed, when you take the catheter out of the uterus, what's hanging off the tip of the catheter isn't a liquid, it's actually a hydrated gel. Now, hyaluronan is ubiquitous throughout our bodies. It's present in the vitreous of our eye and the synovial fluids of our joints. And for those of us who are getting a little long in the tooth, in its cross-linked form, it acts as an excellent dermal filler to get rid of those after lines. But of great significance in terms of reproduction, we had determined through analyzing the literature that the levels of glycosaminoglycans, particularly hyaluronan, increased dramatically in the mouse. And later on it was shown that this is also true in the human, that at the time of implantation, the levels of hyaluronan increased significantly. So these observations led us to develop the hypothesis that hyaluronan had a key role not only in supporting embryo development, but was important for implantation. This is a study we published at the end of last century. And in this work, we were interested in determining the effects of different macromolecules on mouse embryo development. And what we found was not only was albumin beneficial, but hyaluronan was extremely beneficial, and actually the greatest development we observed is in the presence of the two together. Just as they would be in vivo, we found that in vitro, hyaluronan combined with albumin gave us the best embryo development. But it was when we did a series of embryo transfer experiments that we got a really pleasant surprise. And that was when we transferred the mouse embryos in the presence of 0.5 mg per ml hyaluronan, we saw a dramatic and highly significant increase in implantation and fetal development. So really in 1999, we can say, was the birth of Embryoglue. So how does it function? So I'm going to give you now some proposed mechanisms of action of hyaluronan within the uterus. The first one has been tested. If you take a column of uterine fluid and put it in a capillary, and on top of which you add some culture medium, which is basically an aqueous solution of salts and carbohydrates, amino acids, they're rather immiscible. They don't mix. However, if you do the same again and take some uterine fluid and then put on top a solution containing high levels of hyaluronic acid or hyaluronan, they're readily miscible, so they mix very quickly. So it could simply be that by putting hyaluronan inside the uterus, you ensure that the contents of the catheter intersperse with the fluids of the uterus and stay there. But it's now known that hyaluronan can promote cell-cell and cell matrix adhesion, and that would be important at implantation. The human embryo also expresses the receptor CD44 through which it can bind hyaluronan, and therefore there could be receptor-mediated effects. Interestingly, in several other tissues, hyaluronan provides anti-inflammatory and immunotolerance. The significance of that I'll come back to in a minute. But as it breaks down to smaller chain lengths, it increases in its bioactivity, and therefore it's involved in tissue remodeling, but it can also enhance angiogenesis at the time of implantation by augmenting the effects of local factors. So when we look at our beautiful blastocyst invading the endometrium, here's what it has to do. It has to remodel the tissue, it has to induce angiogenesis, and above all, it has to modulate the immune system to prevent being rejected by the mother. So here we have hyaluronan, and its known roles in other tissues in supporting these functions, so hence its supportive role at implantation. So what does it do clinically? What are the data? Well, it's an interesting story. It transpires that as well as improving rates of blastocyst and embryo quality, embryos that have been cultured in the presence of hyaluronan also have a better ability to remain viable following cryopreservation. And this was a serendipitous finding, and it was repeated several times by several groups over the decade from 1999 to 2009. And these are papers that are on the mouse, the sheep, the cow, the human, and the goat. So it's not defined or restricted to one species. It's a number of mammalian species which all reported a highly beneficial effect on cryosurvival when you culture the embryo in the presence of hyaluronan. And some of the work has shown that through ultrastructure, when you examine the insides of the cell of those embryos that are cultured in hyaluronan and look at their organelles, those organelles are quite similar to those from an embryo developed in vivo, whereas embryos that are grown in aqueous solutions exhibit slight changes in their organelle ultrastructure. So it could be that hyaluronan is conferring great benefit through its oncotic pressure to maintain cell structure and function. So from that, we led on to the proposition that hyaluronan should be present in all IVF media. And in fact, for the last 2 decades, I've grown all my embryos in the presence of this, whether it's a mouse, a human, or a cow. So let's consider optimizing our transfer outcome. This is a review that I had the pleasure of writing with Bill Schoolcraft and Eric Surrey nearly 20 years ago. It came out in Fertility and Sterility. And the idea behind it was to explain and document all of the things that we did in Colorado that we had implemented to improve transfer outcome. The first thing that we discuss in detail is the use of ultrasound-guided embryo transfer, which is absolutely, we believe, a prerequisite for successful outcome, as is the inclusion of Embryoglue. In fact, all the transfers for 20 years at Colorado have been done in the presence of Embryoglue, and all the transfers currently at Melbourne IVF, where I'm the scientific director, are all done with Embryoglue. A Cochrane report, the last Cochrane report in 2014 on adherence compounds and embryo transfer, considered 16 randomized and controlled trials. The conclusion from that was that there were improved clinical pregnancy and live birth rates compared to media without hyaluronan at transfer, but also compared to media with low concentrations of hyaluronan at transfer. And such media include the G series of media, which have 25% the levels of hyaluronan compared to Embryoglue. When the adverse effects were examined, they were the same in both groups with regards to miscarriage and ectopic pregnancies. So this slide shows Embryoglue improving clinical pregnancy rates. If you look at the top graph, you can see HA or no HA. And when you look at the odds ratio, you can see there's a significant shift to the right, which means there's a highly beneficial effect for hyaluronan. When you look at HA or low HA, again, when you look at the odds ratio, you can see there's a shift to the right of the line, which is in favor of hyaluronan. And again, that is highly significant. When you extend this to looking at the effects on live birth, the same holds true. You can see the odds ratio is fixed in favor of hyaluronan for both no or low hyaluronic acid. So this paper is the largest prospective randomized trial that was powered for transfer outcome. I think that's a very important thing to consider. This was powered for transfer outcome. And it's a total of over 1,200 consecutive fresh embryo transfers on day 3 and on day 5. And the conclusions from this prospective trial was that the use of Embryoglue significantly increases implantation and pregnancy rates for cases of both day 3 and day 5 transfer. And interestingly, the beneficial effects were most marked in women who were over 35 years of age, which, let's face it, constitutes the vast majority of our IVF patients. There was benefits for patients who only had poor quality embryos and women who had had previous implantation failures. When we take the delivery rate from this largest single study to date, you can see that overall there was an 11% increase in the delivery rate per patient, and that on day 3 and on day 5, there's around a 10% increase in delivery rates. And when you look at live birth rate, children born pre-embryo transferred, there's an 11% increase when Embryoglue is used to transfer the embryos. It's really important to consider this for a moment, because the only difference between these two groups is that all embryos were cultured in G1 and G2 in the presence of hyaluronan, but the gray column on the left, those embryos were transferred in medium G2. Those column on the right, those embryos were transferred in hyaluronan, high hyaluronan and Embryoglue. It's quite a remarkable observation. So since the Cochrane report, a review of PubMed over the last 20 years has revealed a total of 19 clinical studies on Embryoglue, of which 13 reported significant benefits, particularly in women, again, over 35 years of age, for frozen embryo transfers, and for patients with implantation failure. Significantly, of those studies not reporting a benefit, none reported any adverse outcomes. And indeed, those studies that did not show a benefit tended to be very small, retrospective, were not powered for outcome, and indeed typically didn't use the same media throughout. So there's a combination of media effect to consider in those studies too. So I think from the data, it's fair to conclude, with regards to Embryoglue efficacy, that there is a relative improvement of 28% in implantation rate, culminating in a 30% relative increase in pregnancy rate. And the most importantly, we see a 20% relative increase in live birth rates. I think that's truly impressive. Hence, I think it's fair to say, since it was identified as a key facilitator of implantation at the end of the last century, Embryoglue has stood the test of time and has shown that it results in significant improvements and clinical outcomes in human IVF. No other transfer medium in the history of IVF has had its development so steeped in physiology or thoroughly evaluated as Embryoglue for embryo transfer. At the ESHRE, a new package style was released, and that's excellent for those people who are doing less than 5 transfers a week. So with that, I'd like to thank you all and wish Embryoglue a very happy 20th birthday, and I'm happy to take any questions.
Thank you, David, for this excellent presentation. I'm sure our audience is now convinced they should use Embryoglue to optimize transfer outcome. There are some questions for you. The first one is, why add anything other than albumin to culture and transfer medium? Are you not making things more complicated than they need to be?
That's a very good question. I know there are a school of thought out there that media should be as simple as possible, but I have always argued that we should make media as physiological as possible. And I think we have shown categorically that, and not just my lab, but several labs around the world, and I've published many papers now that show that there's this synergy between albumin and hyaluronan in the culture medium. So I think it's actually remiss not to add hyaluronan to our culture and transfer media.
Thank you. The second question is, are you currently working on improvements to Embryoglue?
Absolutely. This area of peri-implantation implantation is something my lab has been focused on for a number of years. And yes, this will ultimately lead to improvements in the transfer medium that we currently refer to as Embryoglue. Absolutely.
Thank you. And the next question is, do you use Embryoglue in your clinics?
Yep, I think I addressed that one already. We use that for all our transfers. Yeah, I wouldn't do a transfer without it, knowing what I know about the glue.
Great. So next question is, why not simply add serum or dextran to increase the transfer medium viscosity?
That's actually a very good question. It's thought that you could just increase the viscosity of the transfer medium because, as I alluded to, uterine fluid is more of a hydrated gel. So if we could increase the viscosity, would that not have the same effect? So there was lots of work done on increasing viscosity through sugars, particularly dextran, and they had absolutely no effect on transfer outcome. During the 80s and 90s, as well as putting serum in the culture medium, typically the transfer catheter had up to 20% serum. But again, studies have shown that that made no difference at all to transfer outcomes. So simply increasing viscosity is not what it's about. I think where hyaluronan comes in is that it actually changes the physicochemical properties of the solution. And I would add, I would like to say that, you know, the data exists to show that serum is actually the nemesis of the embryo. And it's the last thing I'd want to expose an embryo to, let alone put it in high concentrations of it.
Thank you. And so the next question is Embryoglue suitable for all patients?
I would say categorically yes. The data to date shows that patients over 35, which is the vast majority of our patients, repeat implantation failures, etc., but even for the younger patients, you don't know which of them are going to be a repeat implantation failure. So I would argue, why would you take the risk of not using the Embryoglue? And so hence, yes, I would use it for all patients.
Thank you. And so the last question is, we are doing more and more PGT. What about Embryoglue for biopsied embryos?
Again, a very good question. PGT embryos have two things. Number one, they've typically undergone a biopsy, so therefore have had some degree of cellular trauma. And secondly, they've undergone cryopreservation. And I think one of the things the data shows quite clearly, excuse me, is an advantage for embryos that have been cryopreserved and to use Embryoglue. So I would think that the PGT embryos make an ideal group for the use of Embryoglue at transfer, yes.